Hi, everybody. Today we're going to talk about heat or thermal energy. So, what is heat? Heat is energy that is transferred between two objects or substances of different temperatures. Heat typically flows from a warmer material to a cooler material. And heat energy moves in three ways: conduction, convection, and radiation. So, here's a real life heat transfer example. Let's say you take a glass of ice water or a bowl of hot soup and let them sit out on the kitchen table. What will happen? I want you to think about that for just a second. What will happen to them? Obviously, we know that over time the soup will get cooler and the ice will melt in the glass. So, why does that happen? Part of it happens due to conduction. Conduction occurs when energy is passed directly from one item to another. Conduction transfers heat through direct contact. So, where was the conduction in the soup example? Right. The soup was sitting on a cooler table, or the bowl of soup. The heat from the bowl went down into the table. So it's transferring away from the soup into the table, which cools the temperature of the soup down. Metals are excellent conductors of heat. Some materials, such as metals, are good conductors of heat, while other materials, such as glass, wood, plastic, and air, are not. Materials that are not good at transferring heat by conduction are known as insulators. This is why a pan is usually made of metal, while the handle is made of a strong plastic. The metal heats up, the plastic does not. Some examples of conduction. Best example of this phenomenon would be to take a metal bar and heat one end of it. The other end will get warm and then hot through conduction. So when you put a metal pan on the stove, the inside of the pan gets hot through the conduction of heat through the metal in the bottom of the pan. The burner is warm, transfers into the bottom of the pan, and then that heat radiates or transfers up through conduction up through the sides of the pan. Second one, convection. This is where air or liquid moves away from a heat source. Some examples of this would be heat waves, ocean currents, El Nino, or even an attic vent in your house. So, how does blowing on your soup speed up convection? Right, cools off the top layer faster. When the top layer is cool, the warmer liquid from below floats to the top or in a circular pattern, convects up to the top, and the cooler falls to the bottom of the bowl, cooling it down. The third type would be radiation. Radiation is heat that you can feel without touching. It is the only heat transfer that does not require matter. So think about in outer space. We feel the heat of the sun, but we can't touch the sun, and we know that there's no matter directly between us and the sun. In space, it's more of a vacuum out there, so it can travel through that open area. Some examples: our eyes are unable to see infrared, but our skin can feel it. In fact, infrared is what burns our skin if we're out in the sun for too long. About half of all of the sun's energy that reaches us comes as invisible infrared radiation, with the rest of it visible to us as light. Some other examples: an electric heater, a toaster, or even the bricks around a fireplace, or even an open fire. If you put rocks or bricks around a campfire, they get hot and then the heat radiates up away from them. So in looking at this example, soup is heated in the pan by convection. Here you can see the convection currents. The hot soup rises and cool soup falls to take the hot soup's place. Goes both directions in there. The pan handle is an insulator, which doesn't conduct heat very well, and heat energy from the stove is transferred to the pan by conduction. So, can you explain why you feel warm when you were standing away from a campfire? It's actually two different types of thermal energy in place here. The convection currents, which are the hot air that's moving up and out from the flame itself, and then radiation, where the heat of the fire warms you up at a farther distance. Another question: why does a carpeted floor feel warmer to bare feet than tile or wood, even though all the surfaces are the same temperature? Yeah, conduction. The carpet can insulate the heat better than tile or wood. So that even though our feet are directly on all three surfaces, the carpet acts as an insulator. So can you match these examples? Remember, your choices are conduction, radiation, and convection. Ocean currents, a hairdryer, a light bulb, sunlight, or a hot cookie sheet. So if you chose convection for the ocean currents, radiation for the hairdryer, radiation for the light bulb, radiation for the sunlight, and conduction for the hot cookie sheet, good job. You got these concepts down. So here at the end of this, there are a couple links for a couple different songs about heat. As with every other time, I'm not going to go through and ruin your day with actually playing them here on this video, but you have access to all of this, and all of those links are available to you.